Welcome back to the Tech and Code Report. Today, we are breaking down the architecture of modern AI development. If you are building LLM applications, you are likely using the Lang ecosystem. It consists of three core layers: LangChain, the builder, LangGraph, the orchestrator, and LangSmith, the observer. While LangSmith handles our tracing and debugging in the background, today we are focusing on the ultimate architectural decision you have to make: LangChain versus LangGraph.
We are moving past simple chatbots and building autonomous agents that can reason, act, and correct themselves. To do this, you have to understand when to use a linear pipeline and when to use a cyclic, stateful workflow. Let's step inside the architecture. Let's start with the foundation, LangChain. Think of LangChain as the concrete and steel of your AI application. It provides the building blocks to connect your prompts, your context, and your large language models into a single sequence.
LangChain operates on what we call a DAG, a directed acyclic graph. Directed means the data flows strictly one way. It moves from your prompt and retriever straight into the LLM and directly to the output parser. Acyclic means there are absolutely no loops. And graph means the execution is highly predictable. It acts just like an assembly line in a factory. It is incredibly efficient for rapid prototyping, standard Q&A bots, and data extraction. But it has a strict limitation. If the LLM hallucinates or a tool fails at step 2, the chain breaks. It cannot loop backward to fix its own mistakes. Under the hood, we build these linear pipelines using LCEL, LangChain Expression Language. As you can see in the syntax, it literally uses the pipe operator to physically link these nodes together. The code matches the architecture: clean, readable, and strictly linear.
But what happens when you need an AI that can think through complex problems? That is where we introduce LangGraph. LangGraph shifts our architecture from a linear DAG to a stateful cyclic graph. This introduces loops and conditional branching. Now, the agent can route to a tool, execute a function, and evaluate the result. Through conditional routing, it asks, is the task complete? If yes, it finishes. If no, it loops back to try a different approach.
To make these loops work, LangGraph relies on state. State is a global memory bank. Every time the agent takes an action, it appends a new message to this shared context, ensuring the AI never loses its train of thought. Because of this memory, we can build multi-agent systems that look more like a complex subway transit map. Data can hop between a research agent, transfer to an execution agent, hit a conditional delay for human-in-the-loop approval, and loop back seamlessly. In code, this is handled through node functions. Each node takes in the current state, processes its specific logic, and returns an updated state back to the graph. This allows you to scale from a simple prompt to a massive, orchestrated network of specialized AI agents working together securely. So, the final verdict: use LangChain when you need straightforward, linear pipelines for predictable data processing. Use LangGraph when you need stateful memory, loops, and autonomous agents that can correct their own behavior. If this architectural breakdown helped you understand the ecosystem, make sure to subscribe to the Tech and Code Report. See you in the next video.